Assalamu alaikum, Dr. Munder from University of Science and Applied Technology. We continue the second lecture and we will explain one of the classical cryptography algorithm is called one-time pad. One-time pad is a very interesting algorithm. It's basically one of the vinegar cipher type. It's considered as one of these types. It just fixes all the vulnerability or the weakness that exists in Vinegar cipher, so we can consider it as a transposition or substitution cipher. It is a very strong one. It is unbreakable cipher because the key is a random string. It is at least similar length to the text. It has to be the similar length as the text, similar to the vinegar. So the key length must equal to the text length, which is the same property in vinegar. But the only thing is that the key is a random text. Is what? Is a random text made of random, so and used only what? And used only once. Used only once and destroyed by the sender and receiver, and they will never use it again. So if someone got the key, there's no chance to understand the rest of the communication because the key is different will be in the rest of the communication. You can try the algorithm online and see how it looks like, but let's just explain the main things. In order to explain it, I'm gonna go to the Excel and explain it directly in Excel. But let's just give you an overview. So the text I want to encrypt is life is short, and the key I'm gonna use the key encryptions. Okay, the key length is same as the text length. So I put the text here, and I put the key here. Okay. So this is the text and this is the key exactly. Now these numbers is basically the order of the letters. So we have A, B, C, D, and so on until Z. Okay. Now the order of the letter is 1, 2, 3, 4 until 26. X, Y, Z until 25 in this case 25 letters. So this is the order of the letters. So the order of L is 12, the order of Y is 9. We put it in the second row, and this is the position of the letter in the alphabetic order. Okay, T is number 20, H is number 8, E is number 5. You say A, B, C, D, E. So E here comes as number 5, and then we put the key. Okay, the key is the same way we put it. It has to be the same length as the text itself, and then in the row below the key we put the order of the letter in the key. So E is 5 as we said, N is 14, and so on, similar to the way. Now in the encryption, we're doing the encryption now. What we do is we add this number to this number. What's the total of 5 and 12 is 17. 9 and 14 will come up to 13. And 6 and 3 is 9, and so on until we come 20, and 19 is 39. Alright, so we add them. This is only the sum. Okay, the sum of the value of the text, the plain text, and the key. Now the cipher text, we will have if the number of the addition number or the total number is more than 26, then we subtract 26 from it. So for example here 17 is letter Q, 23 is letter W, 9 is I, 23 W. Now 34, we don't have 34, we have only until 26. We start, you can start from 0, you can start from 1. I start from 1, so the last letter will be 26. Alright, if I start from 1. Now 34 minus 26, 34 minus 26, that will come up with what? With 8. So 8 is H. If the number is more than what? If the number in here is more than 26, we take the number and subtract it from 26. The result will be gone in here. So you can see that we have a few numbers is more than 39, come 13, 34. So and then we take the letter in that order and put it. This is the encryption. Okay. I'll give you a good way to understand the algorithm. So let's go to the Excel. Okay. And I will show you. Now this is the plain text. You can spot the plain text here. You're gonna put the value of the plain text and then we have the key, and then when key value, and then we have the sum, and then we have leave one space, and then we have the cipher text. So this is the letters. I hope you can see the letters. Okay, I'll just put it in bold so you can see it. Now we give this letters order from 1, 2, 3, and then I can give them order until what? Let's see. And the letter is I, K, L, M, N, P, Q, R, S, T, U, V, W, X, Y, and Z. Alright, and we'll continue the numbers. Okay, and now this makes this one short so you can see the full screen. Okay, now what's the text I'm gonna which is live. I'm gonna put it live is short. Okay, live is short. All right, now okay, this is the same word we are using in the there. Okay, the same word I'm using in the text here. Live is short, same exactly, to make sure. Now we'll take the order. Where's L? L is number 12. Is it the same in that one? Okay, L is number 12. That's much better now. Okay, you can see that L is number 12, and we can put the order. So L is number 12. We can go to the I is number 9, and we go to the F is number 6, E is number 5, and I is number 9 again, S is number 19. Okay, this is S, number 19, and we have 19 again. H is number 8, and O is number 15. Okay, and R is number 18, and T is number 20. Okay, it is the same as in the one. Okay, the same as in the example in the slides. All right. Okay, now we took the value, we write the key. The key is what? Encryptions. It has to be the same length as the text. So we say encryptions. Okay, this is the key. Let me just make them in the middle so you can recognize the letters. Okay, and also these things. Same thing. E is number 5 here. Okay, E is number 5. N is number 14. C is number 3, R is number 18, Y is number 25 here, 25, and P is number 16, T is number 9, 20, T is 20, I is number 9, O is number 15, N is number 14, and last one is S is number 19. So we got this. Now we calculate the sum. Okay, I'm just gonna use the function from here, sum. Okay, I'm gonna add this one and this one and say okay, and then we can well, this one. So this is the total. All right, this is the total. Now this one, which one is make it red? We have 35, 36, and 39. We have 32, 39. These are more than 26. So this one will be the same, but this one 34, 34 minus 26. So I have to subtract it from 26. I would say okay. I'll put this number equal to this number minus actually 26. All right. So come up to 8. Same thing we'll do this one and this one, and also here I'm gonna say equal this number minus 26. Yes. Okay. I'll just make it a little bit bigger. This is not minus, this is equal, minus 26. So 4, and we can use this for the same thing. So now let's come back to the letter. Number 17 is, which one is number 17? Q. Number 23 is W. Okay, this is W. Number 9 is I think, and number 23 is again W. We have 23 again. Number 8 is H, as you can see here, H. Number 9 I, 13 is M, and 17 is a Q again. Number 4 is D, number 6 is F, you can see here, and number 13 is again M. So this is the ciphertext. This is how we do the encryption. This is how exactly we do the encryption in this one. If you want to make it a little more bigger, you can see it like this. Alright, this is how we do the encryption. Now the decryption is the opposite. Okay, so if I have this one and I want to decrypt it, okay, just go to the opposite way. Alright, I'll go to the opposite way. I'm gonna say take this one, ciphertext, and I'm gonna copy it and make sure if it comes the same or not. So this is the ciphertext. Then we just make it smaller and smaller a little bit. Okay, now I'm gonna do it right here. Right, this is the ciphertext. Okay, I will take the position of the ciphertext, which is basically here Q is 17, W is 23. You can see W here is 23, or you can take I is 9. I think I is 9. This is decryption. This is what? This is encryption. Encryption. Now I'm doing here decryption, the opposite. Alright, now the decryption is very easy way to do. So I is 9, W again 23, H is 8, and I is 9 again, M is 13, Q is 15, and D is 4, F is number 6, and the last one is M, which is number 13. Alright, now this is the value for the cipher. We call it cipher value. We put the key here, so we copy the same key and the key value. So the key is encryption, same. Okay, this is the key. If we try to get the key value, you can get it from here. Just gonna copy it from here because it's gonna be the same numbers. Okay, but you know how to get it. And then the last thing, I'm gonna do what? Not the sum, I'm gonna do subtract. I'm gonna do what? Subtract. Not sum, subtract. Okay, 17 minus 5, it will come up to what? 12. 23, okay, I can show it to you here. So I'm gonna use the subtract. This one is equal to 17 minus number 5, which is end up to 12. I'm gonna do this for the whole thing here. You can see that we have minuses here. Okay, we have minuses here. We don't have number in the position minus 17 or minus 7. Okay, so what we do here, we try to make it work. So we need to see the difference between 17 and 26. Alright, so what we do is we just say this one is equal to 26 plus the number, which is equal to 9, and I do the same for the rest. Okay, and the same thing here. Okay, I'm just gonna have to do it for the rest and remove the C because this one is not included. So here we got 15, 18, 20. These numbers are not minuses, so I put the letters. L number 12 is L. Okay, this is L number 12. So this is the text. Okay, L is number 12. Number 9 is, I think it's I. So I. And number 6 is F. Number 5 is E. Number I. Number 19 is S. 19 is S. And number 19 is also S. Number 6 is F. Okay, and number 6, okay, is F. Why this one is number 6? Why it comes to 6? This one, 15 minus 9. Q is 15 and I is 9. 15 minus 9 equals 6. So let's just put it. Okay, 6 is F, and we have 15 is O. Okay, this one's supposed to be H. We have error. We'll find out the error. Okay, this one is O. 15, which is the same. O, and number 18 is R, and the last one is 20, which is T. Alright, so we have an error here in this line. We're gonna find out how we encrypt it. So H is number 8. Okay, H is number 8. This is H number 8, and it come up I is number 9. Okay, I is number 9. So 8 plus 9 equals 17, and the letter in 17 is Q. Alright, This is correct until now. So Q here is not 15, sorry. We have a mistake. Q is 17 here. Alright, Q is 17, and 17 minus 9 will be 8, and this one will be H. Alright, so it come up the same word here is exactly the same word here. Okay, they are the same word. If you do the encryption or decryption, and this is the cipher text as well, you can see it's the same. Alright, so it's supposed to be very easy. And remember, in the encryption we do the sum, and in the decryption we do what? Subtract. In the encryption we do sum, in the decryption we do what? We do subtract. Very easy and simple. Alright, this is how we do the one-time pad. I hope you understand that. This is the decryption and encryption, supposed to be easy. Now, the problem with the time pad is that the key must be long as the plain text. Okay, the key should be long as the plain text, and the problem, if you have a plain text with 100 letter, you need a key with 100 letter, which make the algorithm a little bit complex. All right, and also does not guarantee integrity. Okay, it guarantee confidentiality, that the message will be secret, hidden, but it does not guarantee that someone will change the message. Okay, he could replace one of these letter with the other, and this will become will change the message and will violate the integrity of the message. Attacker can recover the plain text, but cannot recover the plain text, sorry, but can change something else. This is the second problem, does not guarantee integrity. Now, insecure if the key are reused again. If you use the key, the same key, and again, this will cause a problem, because the attacker can do XOR with the plain text and get the text again. So this is some of the problems that exist in the one-time pad, which is the key must be long as the plain text, and does not guarantee the integrity, and the text will be not be changed, and if the key is reused again, it will become insecure. Okay, it's hard to break, but if you use the key again and again, it become insecure. This is an activity for you. You can try to encrypt wheel of encryption and use this key for you. Okay, try to practice that and see, do the encryption and do the decryption and see if it's the same or not. So at the end, we already classify cryptography based on number of keys, based on the text processing, based on the operation type. We also study the substitution and transposition, and we say substitution is mapping, transposition is rearranging, and we said that symmetric use single key, asymmetric you use more than one key, private key and public key. Caesar cipher and Vinegar are example of substitution. Rail fence and Playfair are an example of transposition cipher. And the one-time pad cipher is a type of Vinegar cipher. We also describe some category of cipher depending on various criteria, such as the processing way of a blocks or stream, modern or old, something like that. And we apply some traditional symmetric cipher during that, and we give you some activities. This is all about classical algorithm. Now, next lecture we'll talk about modern cryptography.